Excellent. Well, it's a real pleasure to be here chatting with you all about these really important topics. One of the interesting things that came up repeatedly around the last discussions and will come up all through the day is just this incredibly valuable interplay between gathering of evidence and use of evidence. So part of what I'm going to do will have a slightly different flavor. I'm going to talk about what do you actually do holistically with evidence and learning science and practices at scale. How do you put this all together? So, and I think of this really as learning engineering, and that's really what this is going to be about, is both how to think deeply about what learning science and good evidence practices suggest about how you should intervene, and then how do you think about making changes at scale to learning systems, which is a little bit of what came up at the end there about how do you think at a systems level. So the first thing is just to ground ourselves in the opportunity for minds, which is very large. There's a bunch of different studies, especially human tutoring studies, one-to-one tutoring studies, that clearly show, you can take a bell curve of minds and push them to the far right-hand edge. It's really important to keep grounding on the fact that our challenges with education and learning and training are not really because of what's in the students' or learners' heads, whether they're kids or adults. We actually have highly inefficient but effective processes that can be deployed to be helpful. Our challenge collectively is we can't do that at the massive scale that our modern society needs. So, part of this challenge then is, well, what do you do? How do you actually try to think about the at-scale problems that we all have? So as you heard, I've worked in a range of different institutions, but since my time doing research at MIT, at the Artificial Intelligence Laboratory, I've really been trying to work at scale to try to bring ideas from the laboratory and the developing work over the last several decades into practices that actually work at scale. So one of the ways that we've been thinking about this within the organizations that I've been in, and now at the Zuckerberg Initiative, where I am looking after how do we use evidence at scale to make changes, is to start from how does learning actually work? There's far too much work going on, especially at scale, based on aspirational theories of how learning works. Wouldn't it be convenient if minds could be bucketed into little blocks of learning styles? So all we have to know is, are you kinesthetic? Are you a verbal learner? Are you a visual learner? And then, hey, we can make a big difference by assigning you for the rest of your life that kind of learning. Wouldn't that be great? Okay, yeah. Do you really want to be the world's best paper-mache automobile bridge builder? Wouldn't it be great if we could build bridges for cars out of paper-mache? Because I love paper-mache. Well, the problem is paper-mache will not ever work in the rain to hold cars over the water, no matter how much we wish it were the case. So part of the challenge is really, we got to ground ourselves on how learning actually works. And as we'll talk about, and many of you already know, and have experienced this, learning is often really inconvenient. It doesn't look like it's a well-designed system at all. Folks like John Sweller have actually hypothesized that for evolutionary reasons, it was valuable over 1 million years to actually make it quite hard to master things, because that way it repeatedly had to work in your hands before you burned it into your brain. Well, the last 40 or 50,000 years, we've had other ways of mastering things besides repeatedly doing things ourselves and seeing if they work or not. And yet, we still have this really inconvenient system that we can't turn into a tape recorder, right? Just tell me what I need to know, boss, and I will execute perfectly once you finish telling me what I need to know, right? So it's desperately inconvenient, but that's a very important piece of this, is to ground it in how learning actually works. The second thing that comes up, and this came up a little bit in the panel discussion too, is, well, what's the role of technology? And too often, people will often move directly to technology and say, this is great. If we can just get everybody an iPad, clearly that will be engaging and exciting, and that will make the difference. Or an iWatch, or pick your favorite technology. It used to be radio in the 1930s, right? That many departments of education at state levels built radio stations and hired lecturers because they were going to overcome the bad teaching in our state by having the very best teachers give radio lectures. It's funny how even the revolution of MOOCs 4 or 5 years ago kind of forgot the lessons of the 1930s, that it's not enough to just broadcast the best lecturers. That, again, learning is inconvenient. We wish that that was enough. Without the practice and feedback environments and the social connections, it's not going to work no matter how much we wish. So you could make a start claim, as Richard Clark did a number of decades ago, that technology actually does nothing for learning. What technology does is take a good learning solution or a bad learning solution and make it more affordable, more reliable, more available, more data-rich. But it does it for bad solutions. So here's a thought experiment. Think for a moment of your worst ever college instructor, right? Everybody's got somebody in mind. It's like, yeah, I can see the smiles appearing. Yeah, you know who I'm talking about. Okay. That person, before technology, used to only harm a few thousand students per year. Thanks to the glories of technology, that person can destroy the life aspirations of millions of students around the globe, 24/7, right out to Kazakhstan. Win for technology, yes? Aren't we glad? No, it's a disaster. Because it's not about the technology. It's what are you using the technology for? So you got to get this in the right order. How does learning actually work? What are the learning problems you're facing? What evidence do you have about a new thing a mind should experience that's better than what it's already experiencing? And then you reach for technology. How can technology make that more affordable, more reliable, more available, more data-rich? And then the last piece here, and this is part of where technology can really give an angle compared to previous generations of teaching and learning, is you then use evidence to make progress. Now, it used to be really expensive, and many of you in the room have been involved in coding studies, looking at video of students and teachers working together, or even just watching students do their own work, and tediously hand-coding the events you're seeing and having several raters look at it. The work can be done to do all of that in inter-rater reliable ways, and you can then ground research off of it, but oh man, is that heavy lifting, right? Nowadays, where you've got technology working, you can use the technology itself to set up data and information about usage as well as results. And so can instrument, and people have even created affect detectors and new technologies for looking at eye gazing to start to get a really multidisciplinary or a multidimensional approach to what's going on with students, which again can be fed in, right? And now you can use a rich, rapidly flowing set of multidimensional data potentially to make progress. So to me, this is really why you can have a term now like learning engineering and have it actually make sense. Herb Simon actually used this term back in the 1960s, it turns out, and in a description of what university faculty should do. And he absolutely nailed it. He said, absolutely, university faculty should be involved in using what's known about learning and the outcomes we have and applying those to design systems of learning for students that are iteratively updated with the evidence of success over time. Fell like a rock into a black pool. Not a ripple was left after he made that address. And I think part of it is because the times and the data, and even some of the learning science evidence, just wasn't ready to begin to allow a much more systematic approach to engineering the success of students. We are now at that point. We have a lot of data, sometimes too much. It's pouring in. We don't even know what to do with it sometimes. And it's very easy if you dump it on people, you just confuse them. Well, now that means let's start doing engineering work. What do we want to have happen? What's the data that we need to understand what's happening? Is it valid and reliable data? And off we go. That's learning engineering. One of the really important things I'll emphasize throughout this is we really do need to think about this multidimensionally. It's not just about academic capabilities, nor in fact is it about separating academic capabilities from identity, from social and emotional learning, from cognitive capacities, from even physical and mental health. There was an article in the New York Times just a couple of weeks ago showing evidence that said if you are underhydrated, you're going to be like 20% less effective at problem solving, right? So who knew that one of the best ways to increase your learning and your problem solving was just get them a bottle of water? Breakfast is a powerful learning intervention. I talked to a textbook publisher who discovered that a lot of community college students are now coming to school hungry. And she said, what am I supposed to do about that? I'm a textbook publisher. I create online media. There's nothing I can do to provide them with breakfast. And yet, that may actually be the most powerful intervention for many learners. So you really have to think about all of these things at once. This is one of the things we're trying to do at the Chan Zuckerberg Initiative, is really raise the visibility and the capability of our ecosystem to pull all of these things actually together. So as an example, you know, we think about the whole child, in this case, some little chaotic critter called Bror there. There's a whole bunch of dimensions that Bror is experiencing at the same time. And yes, I was the person who said he had really bad handwriting as a little person, so that's what I'm going to use for this, right? So horrendous handwriting, right? And yet supposed to make progress somehow on writing, right? What are we supposed to do? And there are standard activities. So my first grade teacher, literally, the standard activity was everybody's got, or second grade teacher, everybody's got to write a little sentence or a couple of sentences every week, and then she'd give feedback and you'd revise it and off you'd go. That was the standard activity, right? I did that standard activity the first week and I knew what was coming. She called me to her desk and I thought, here we go. I'm going to get hammered for my writing again. And she said, I cannot read this at all. And I was like, yep, here we go. And she said, I'll make a deal with you. Here's the deal. We're going to do this every week. Everybody else is going to write. But if you'll agree to give a talk every week instead, I was a second grader, right? So I was, what, 7, 8 years old? I will get what I need from you, which is, can you put an argument together? Can you make a sequence of things? You know, and that way, I won't have to read your writing. So win-win, right? So customized activity for little Brewer, right? Leading to, and it's important to emphasize, multidimensional change, right? Because think about what happened. Not only did I get practice and feedback on what she thought was the real core skill that she was after, which wasn't my handwriting, it was argument. But think about what it did for my identity. I had already been spent 2 years being beaten up for my handwriting. Nearly didn't get out of first grade, because I violated the rule that you had to be still able to be legible on one line, right? So I was beginning to develop an identity as a bad student because of my handwriting. And that whole second grade year, just transformed that. I had no identity as a handwriting human being. I did have an identity as an argument-using human being, right? So it was not just an academic transformation, right? And of course, positive social and emotional stuff, I did something that contributed to the whole class. They laughed at me a whole lot. That was all fine. And so this is the kind of transformative learning thinking we need to start institutionalizing and systematizing. Which kids need breakfast? Which kids need water? Which kids need support for horrible handwriting? And change what you're actually after to focus on the important things, and do it across all these dimensions at once. That's the other piece to think about. And this is, you know, teaching is a performance art, right? It's an unbelievably difficult act because it's basically improv with lifelong consequences, right? No pressure, right? And how can you do that? So when you read the research and you see, yeah, there's 6 different domains here of multidimensional goodness, and each of those fragments down, and each of those have research on good moves to make, right? It looks like it is impossible to be a teacher because I can't do 16 things every 3 minutes, all right? So part of what we all have to sort through, this is the at-scale problem, is how do we design integrated, coherent experiences for students and teachers and technology and data that do 16 things at once, but they're not 16 separate things. They're a thing that happens to hit 16 different levers all at the same time. And too often our research approach, which has helpfully divided things up so we can put a lens, a light on individual pieces, can lead us to think it actually is separable. You cannot pull out the math processor and tinker with it for a kid, pop it back in, and then pull out the identity processor and work on that separately, and pop that back in. No, what you do for that child in math is going to affect their identity as a math-using human being and maybe other things. But you need to be aware you're affecting multiple subsystems, but it's a coherent interaction that you have to actually go after. One of the things that I think is really important to ground ourselves in is that notion I mentioned earlier. How does learning and expertise actually work? And we know actually a lot about this. This is work that comes from Rich Mayer and John Sweller and a whole range of colleagues around the globe over 30 or 40 years, looking at how minds actually work. This is a really simplified version. Remember, I'm an engineer, I'm a carpenter, right? My cognitive science colleagues in the audience will be very upset with me for doing this, but that's the right relationship between engineers and scientists, right? We engineers, we simplify things down, we lose all the juice, but that way we can actually build and work. And the scientists, they work at the corners and the edges and they make new things, and that's good too, right? So I'm going to show you a simplified model that I've actually been using in multiple organizations for how to train instructional designers and teachers how to think about learning and expertise. So really simple model is to say you got audio and visuals coming into working memory. So working memory is very narrow. It can only handle a few things at once. It's verbal. It's where your talking part of your mind actually acts and executes. It is error-prone, but it is also highly flexible. It's where the new stuff, new problems and learning has to go first. It's where you get new insights from. The problem is the noisiness, the slowness, the error-proneness of it means, boy, if that's all we had, we'd be in real trouble. Working memory, however, is deeply supported by long-term memory. Now, long-term memory has completely different characteristics. It has longer retention. It can do many things in parallel. It's also not very error-prone. If it's been trained correctly to be error-free, it will act nearly error-free, but it's very rigid. And it actually has machinery that allows it to actually notice I am out of my comfort zone and throw a problem back to working memory so that you're suddenly thinking about the problem again, and off you go. Another aspect of it that is, again, enormously frustrating and inconvenient for learning and instructional design is long-term memory is non-verbal. Non-verbal. So here's a working example. Who here drives a car? Raise your hand if you drive a car. See, I tried this in Singapore. It was a disaster. Okay, great. So who here has had the following experience? You set out for place A, and then you start thinking about UCLA or Washington, D.C. or CREST or whatever it is, and you look up and you've ended up at place B, a different place. Raise your hand if that's happened to you. Look around, you're not crazy, not for that reason, okay? There's a lot of people who've had that experience. And I'm usually ending up at a Starbucks, I'm usually under-caffeinated, need some more help, and so you just laugh and you say, shoot, I gotta go to the right place. What we don't do is think enough about who drove you to the wrong place? No, seriously. Who was in charge of a ton of metal going 30, 40, 50, 70 miles an hour for 5, 10, 30 minutes, right? Because it wasn't you. You, the verbal you, was thinking about other things, right? So this is long-term memory can do complex cognitive tasks over an extended period of time. Because remember, driving is not like digesting a bagel, right? I have no idea what happened to I don't want to know what happened to my bagel this morning, right? But driving is a learned experience. It's not an evolutionarily part of your nervous system. It's a learned experience so deeply mastered. Complex decisions about path and judgments on other people and speeds and navigation can be done without conscious reflection whatsoever, right? So when you're driving home today, look left and look right, and you can wonder who's driving those cars. Because it's not who's going to get out when there's a fender bender, right? Everything is being done automated. So think about the consequences of this then for instructional design and for teaching, right? We should be thinking a lot more about, well, wait a minute, what do the top performers actually automate? Because not everything is automated. Driving, a lot of it is automated, and you can plan a summer vacation while driving. But think about writing a persuasive essay. You cannot plan a summer vacation while simultaneously writing a persuasive essay, because that kind of work is always a collaboration between working memory and long-term memory. You draw on a whole range of automated capacities to write a sentence or a paragraph or punctuation or evocative language or whatever it is, but the issues of argument and tone and where is this going, and is this a good thesis? That's working memory stuff, right? So very often what we should be thinking about is, what do we need to make sure our learners, whether they are kids or adults, have actually automated by looking at our top performers? Because sometimes, when I was a student of engineering, now a long time ago, in the late 1970s, this was 3-4 years after scientific calculators had come out, and they still insisted we were fluent in using a slide rule. What? Well, it was obviously a dumb idea. Oh, people would say, well, what are you going to do if the power goes out? My answer was, I'll take a nap. What do you mean? I'm not going to build some some new aerospace device without power and do it on a slide rule. Are you nuts? And yet there was still this sense of, well, no, that's what we do. We are good with slide rules. And it's like, no. So we should be careful to look at who are currently top performers and then ask, what do they automate? And then start working towards, and what else do we need to be able to do and decide and do, and how does that collaborate with that? And as I said, one of the really inconvenient things is you can't just ask long-term memory to tell you what's going on, because you don't have verbal access to it. So you have to do, and we'll talk about it, some more difficult mechanisms to actually unpack all that. So last piece of this machinery works for more things than just academic or workplace skills. This same machinery applies to things like identity, social and emotional learning, and so forth. So often what happens is, how you grow up, what happens around you, puts into long-term memory certain reactions, certain assumptions. I'm no good at math. It's instant. I don't have to think about it. I'm no good at it. Well, that's actually not true, and yet it has become burned into long-term memory for some students, or vice versa. I'm not a good writer, period. Well, that gets burned in, so it's an instant reaction. And part of the role of working memory then is to wrestle with that, to overcome that, to figure out what is our strategy, how are we going to do it? That's part of the teaching role, is to get working memory engaged with this instant feeling of, I'm no good at that, to back up and begin to do that work. And there's a lot of practice and feedback to do to try to overcome some things that are burned into long-term memory. Again, another inconvenience, we do not have a delete switch for things that are burned into long-term memory. We don't have an easy way to get rid of those things. Evolution had no reason to put one of those things in. But now, with the increasingly rapid change in how technology alters the workplace, things that you burn in when you're 20, you may have to stop doing when you're 30 or 40 or 50. And that is actually quite hard. Requires a lot of its own practice and feedback. Very inconvenient, but we have to embrace that. A second whole line of research, it's a little more recent and a little less well gelled, is around motivation. If you're trying to get minds to be effective, to produce work results, to learn things, to deliver what you want, to be fluent in certain things, you've got to have minds start, persist, and put in mental effort. And that's a good technical definition of motivation, right? That you start, persist, and put in mental effort. This, if you do this on a well-designed learning activity, you will begin to learn and change your brain. Now, you'll notice liking is not on that list, right? This is like exercise, that you do not have to love the weights to benefit from doing the weights in a good weight program integrated to your sport, right? That it's the actual exercise, the running of the muscle neurons in that case, that makes the change, regardless of whether you like it or not. So there's a lot of truth to saying, yeah, if you can get through well-designed practice, whether because you like it or because you need it, and we'll get to that in a second, that's what's going to make the change. So motivation is not about liking everything you do. It's about doing it, starting, persisting, and putting mental effort. So this Richard Clark, who I mentioned earlier, did an analysis of a whole range of behavioral economics, motivational psychology, cognitive psychology, social psychology literature. And again, this is engineering work, right? So, I've lost all the nuance to all my colleagues who do this work for research, and I apologize to you deeply. But this is practical and has been quite useful to teams in various places, including now at CZI, which is it looks like there's kind of 4 big buckets of things that get in the way of starting, persisting, and putting in mental effort. So here they are. So the first one is you don't value what you're doing or how you're doing it. So I'm a dancer in an algebra class. What am I doing here? I'd rather think about Swan Lake. What is this for? So what's the treatment for this motivation problem? Well, I find the link. How do I make it interesting to a dancer? And there may be many ways. It could be, let's talk about dance foundations. How much money do you need to run one of those things? Because many great dancers, they got to run those things later on. So then it's about modeling, it's about money, it's about discounts. Well, now you're doing algebra, right? So suddenly it becomes interesting, right? A second problem that comes up, different than the first one, is the self-efficacy problem. Like I said before, I'm another dancer in the same algebra class. I can't do math. It's as easy as that. So I'm not going to start, persist, and put in mental effort. I'm just going to be miserable, right? I can't do it. Well, if you come bustling up to me and talk about dance foundations and all the rest, you're just making me miserable. I get it. My life is over. I can't do it. Well, that's not the correct treatment for that problem. The correct thing to do for that is to say, you can do this. We got to back up. We'll show you how you've done things just like this before. We'll find the blind spots, the things that are missing. We'll have you talk to others or hear from others who are in the same place you were, artists or others, and who had the same feeling but got over it by backing up and going forth, right? It's a different approach to treating that problem. A third problem is a little like the second one. It's not that I can't do math, but it's things in my world are in my way. So my teacher hates me, so I don't start, persist, or put in mental effort. That happened to my kids all the time. They would come home and say, my teacher hates me, so I'm not going to do the homework. It's kind of like non sequitur city, people. What do you mean? But that is one of the things. People just, I'm not going to do it because of that. Another is, I can't understand this. What am I supposed to do? I can't understand it at all. Another one could be physical stuff, like I don't have space. I don't have space to work. I don't have a computer. I don't have a cell phone. I don't have coverage, right? And the really popular one among all kinds and levels of professionals, of course, is I don't have time. It's valuable. I could do it, but I don't have time, right? So you have to problem solve around each of those. You don't have time. Let's look at your calendar. Let's figure out where can we make time for. You don't have space. Well, let's look at your commute or your walk or where you live, and let's work on that, right? You can't understand the language. All right, let's find other things. Ever heard of YouTube? I mean, there's plenty of places to go look for alternate ways of explaining this verbally or otherwise, and make a switch in the teachers, et cetera, et cetera. Totally different set of solutions for that motivation problem. The fourth one is arguably the hardest of all, which is negative emotional states. If you are angry, depressed, scared, it's really hard for you to start, persist, and put in mental effort, and that is as complicated as it sounds to resolve. This is really a cognitive science, motivational science version of why we need social services. It's not just about being nice for kids and families. It's literally to stop this from blocking learning, because this really causes you to perseverate and just be unable to focus. So you got to get at this. And this is totally different than the other ones, right? So there's little Bror. He's not working, okay? Now, the first conclusion is little Bror is a lump, okay? and you move on to other people who are not lumps. What this says is, no, little Bror is some kind of lump. Well, what kind of lump is little Bror? Which of these many things, either one or several, is actually going on? Because then you actually have a treatment. You have something you can try to do once you start to figure out what kind of things are in the way. So this is a valuable kind of framework to potentially use with teachers, with systems, with other things to start to say, hey, if students are not progressing, is it because they are struggling cognitively and need a different design for the instruction, or is there actually a motivation problem, that they're losing steam, they're not working? Now, one-to-one tutor can see that immediately just by how you look like you are working. Well, how do we scale that up is actually a pretty important question that I think is going to be coming to the fore over time. And just quickly, all those 6 dimensions, academic, identity, social and emotional, cognitive, metacognitive, mental health, physical health, each of those has its own tie-ins to these motivation things, right? Your identity reactions can hit all of those things, right? Who do you think you are? And I always get angry when I do math, or the fact that I can't do it is just an attribution thing, right? And do I value something in math? Well, it depends. If I come from a home where I've been working on that because my parents are engineers, I instantly think math is valuable. Where somebody else is like, I don't know where I would ever use it. And so you got to build some identity and do some work on that, right? And all of these others, they all have cross connections that are worth actually going after and thinking about as part of the instruction and the design of the instruction. So as you put together kind of the cognitive work and research, and then some of this motivational work, what it starts to allow you to think about is a more systematic approach, a learning engineering approach to how you build environments, learning environments that can be more successful. So one part of this is that what do experts really decide and do? Whether they are expert students or expert practitioners, and the research on this comes out of the cognitive task analysis literature. Often, what experts say they do doesn't actually match what their long-term memory actually does. It's why sometimes it's actually quite hard to do cognitive task analysis with faculty members, even expert faculty members, because expert faculty members have learned words for what they do, and it's really hard to show them the videos of themselves actually acting and for them to discover their words are not what their brains actually do when they're actually practicing, right? And you end up with a battle of words about this until finally the videotape convinces them. So sometimes it's easier to work from people who are not teaching experts because they don't have words for it anyway, and so then they can get busy and try to get that done. So there's real effort. It's hard work to do this. It's inconvenient. But if you don't do this, you're going to miss things. 70% or more of what an expert's mind decides and does is non-conscious. It's tacit. And they teach only that 30%. So if you wonder why first year out of professional schools of all kinds, whether it's doctors, lawyers, architects, plumbers, carpenters, why the first year out is always a disaster? It's because you only learned 30% of what you needed to decide and do to be good at your job. So the next few years is accumulating all that so that 5 to 10 years later, it's all in long-term memory. You can become a faculty member and not teach it to your students too. Woohoo! The cycle continues from Middle Ages on, right? Well, we got to get better at that. The second piece then, and we'll talk a little bit more about this, is using evidence-based approaches to instructional design, and I'll talk more about that. A third thing is, again, this is part of what CREST and this conference is all about, is getting the right learning measures. And one of the things we need to improve the academic and workplace learning measures so that they are more performance-oriented and that they are efficient to mark. So that's where technology comes in. There are ways to do performance measures that are iterative, reliable, and all this, but they're human. And that's really expensive and slow, so there's some great work to be done to figure out how can you use machines to accelerate this. But then there's also the non-academic side. We have very few repeatable measures of your identity development, of your social and emotional skills. And the research tools are all self-report. Well, you ask a 14-year-old over and over again, are you gritty? Are you gritty? Are you gritty? Yeah, they're eventually going to say, I take showers all the time. I'm really gritty. Is that what you mean? Can I go now? You don't get reliable data out of those self-reports when you keep using them. So we need to figure out how can we use the evidence from their performance to actually generate hypotheses about the rest of the picture. How is their identity developing? And there's research to be done on, if you take a well-designed academic activity, how do you alter it and instrument it to give better information about identity, social and emotional, et cetera, right? So there's a lot of great work to be done there as well. And then, how do you use technology and all the rest of it to start doing more rapid pilots, randomized controlled trials that you can accelerate when you have technology-based systems so that you really can be doing learning engineering as opposed to a bit more of the guess and test that's going on. So one of the things that I think is really exciting is about this evidence-based instructional design. We have a lot now of information about how learning works, and even about how to think about learning outcomes. Who here knows about Bloom's taxonomy? That's one that's really well known, right? Well, one of my colleagues from years past, Brenda Sugru, wrote an article that's not titled Bloom's taxonomy is dead, but it should have been, just to be clear. In that, Bloom's taxonomy was created a little bit like Aristotelian physics. It was an armchair approach, best effort, with almost no evidence, to figure out, I wonder how we should classify learning outcomes, because it's clear they're different. And, best effort, just like Aristotle, right? But once you have evidence, you can change this. So colleagues at Carnegie Mellon a few years ago, Ken Kadinger and Corbett and Profitti, they came up with a different kind of framework. Now, and again, their article is 30 pages long. It's an extensive description of this. There's many polysyllabic paragraphs devoted to each of these things, okay? So again, apologies to all my colleagues at CMU. I'm sorry about this. So for engineering purposes, we shrunk that down and trained instructional designers on thinking about it this way. At the top level, you have complex cognitive procedures within a domain, right? And I mean complex, like write a one-page summary of 10 pages of stuff. So non-trivial, okay? So it's like real, it's like hard work. But those kinds of complex cognitive procedures, they draw on a variety of supportive knowledge. So they might draw on some facts, they might draw on some concepts, some processes, some principles. Each of those, actually, there's some evidence about the best ways to teach those different things. So if you've got to get some facts mastered, spaced repetition is the way to go. There's a whole bunch of evidence about how to do that, about how you need to bring them back just to the point of forgetting, a whole bunch of things. People in this room may well have done research on this or implemented models of this. Woohoo, good stuff, right? But learning facts is not at all the same as learning and using concepts, right? That, sure, you could memorize the definitions of concepts by using spaced repetition, but an expert's mind uses concepts to figure out what kind of a situation am I in, and to link those to schemas for solutions. So there's classic work from Chi and Glaser about physics problem-solving mechanics. Is it an energy problem or is it a momentum problem is the first thing that good mechanics problem solvers do. And once you know which one it is, a whole bunch of things become irrelevant and other things you got to know. And so schemas then just rise up out of long-term memory and help you. So conceptual mastery is in part about which is this, and then the linkage to sets of schemas that then help you, right? So there's practice to do that. You got to actually try to classify situations and use them, basically. Processes are, things like the Krebs cycle or combustion engine, sequences of stuff, multiple inputs. And again, it's not enough to just memorize the Krebs cycle. That's not what an expert mind does. An expert mind can tell you almost instantly, hey, if I double this chemical, does anything happen to the outside? Or if I knock this in half, does that alter the output? And an expert mind, yep, they got that. That's part of what they do. And it's harder, but a lot of it is also automated the reverse. If I have a bad outcome from a process, where is the problem? Now that's an underdefined issue, so there's more art to that, but a lot of things are kind of, mastered. When you drive up your puffing white smoke exiting car with a knocking noise to the car repair place, the guy's munching on his sandwich and he knows which tools to pull, right? Because he knows immediately which part of the engine is broken as a result of that, because he's mastered that complex process of ignition and all the rest of it, so knows exactly where to go for that kind of thing. And then principles are, in some ways, the most interesting there. If you are in a fog as an expert and you have no idea what to do next, experts have the starting points. It's like, well, I don't know what's going on, but all right, first things first, and they start with something, okay? And again, often these can be stated in little sentences, and there's not many of them, but you can't just memorize that. The expertise is the use of those principles in foggy situations. And this is one of those that you can't really automate the coaching on. This is where expertise comes in. You need experts to argue with you and to talk to and refine how you navigate complex circumstances. There's more than one way and so forth. But just to reiterate and repeat, facts, concept, processes, principles, often this is what people focus on in courses, but that's not actually what we want. We want people to do complex cognitive procedures for the domain. And that is its own work and its own practice and feedback. Again, it's so inconvenient. If you mastered all these pieces, shouldn't it be easy to put together? And the answer is no. You actually have to design practice and feedback to put these things together in a real-world circumstance to actually do a complex cognitive piece. The first time you do that, even if you've mastered all these, you overload working memory. And it's confusing, right? So you've got to do that kind of practice. So in addition to this kind of work that allows you to have a new scheme for classifying outcomes and therefore defining those outcomes, there's a lot of research. This comes from Clark and Mayer's book, E-Learning and the Science of Instruction, which is a great book on the cognitive side of learning. Research about even simple things about what happens with screens that you show. And again, depending on your mastery level, some things on a screen can be chunked by long-term memory, and so there's only 3 of them. And for other students, everything is its own little piece. They don't chunk together at all. So if I wrote up ax squared plus bx plus c equals 0, some students are like, oh, it's a quadratic equation. He's going to make me factor it. I hate factoring quadratic equations. My life is over, okay? Think about all the pieces there that have been automated, right? There's the recognition of that's a quadratic equation. There's also the identity. I hate quadratic equations, right? It's been mastered, for better or worse, right? Another kid looking at that is like, why are there letters and numbers in the same sentence? What is that? They are having 2 completely different cognitive experiences from the same sensory input, right? So, where you start is really important to this. But there's a bunch of research showing that, if you use relevant graphics and text, it's an eye chart, sorry, you can get in laboratory conditions more than a standard deviation of benefit. If you avoid irrelevant graphics, you can pick up a standard deviation. If you script the audio in a conversational style for hard things, you can pick up almost a standard deviation. And I know, especially with this audience, most of you, like I do, have a bell curve in our main living room because it creates wonderful opportunities for cocktail chatter among the faculty visitors. But if you start at the 50th percentile and you go up by 1 full standard deviation, you've moved people to the 84th percentile. Now, your mileage will vary because those were laboratory tests, done in basement labs here and elsewhere. But I'd rather start from stuff that has this much energy from a laboratory and then lose some of it on the way to implementation than to start from learning styles that has no evidence at all that anybody can make it work, at least not yet. Why would you start with that when you have stuff like this to begin to say, hey, let's at least not cognitively overload the screen. Let's at least match up the words in the text and so forth. Some of this stuff costs nothing to actually do, but has this kind of impact, at least potentially, on students. So when I was at Kaplan, we actually did this to live courses. These were some Kaplan University online courses that had been written in the traditional way of a read, write, discuss course that was a lot like MOOCs are, where the outcomes and the content weren't terribly well aligned. The content was what the professors taught. And then they made up the outcomes afterwards. The assessments were hit and miss in terms of, well, what did they actually pick off? And there was a lot of reliance on discussion boards, right? That was the key thing. Everybody had to go talk about stuff with each other, right? And so we threw the cognitive and motivational science book at these courses and modified the heck out of them. Again, that's an engineering thing to do, right? Because of course all the scientists are like, well, what makes a difference? And our answer was, we have no idea. But we did the whole thing to see if we could move a needle to start with, and then we could get more detailed from there. And so we aligned the outcome and the content. We got one lesson per objective. We actually had motivational pieces that were called out separately for teachers to go intervene on that front. And what we were able to show is a significant improvement, 1,000 students. And again, Kaplan University is a virtual university, so it made it easier to do this kind of experiment. We had 3 different courses, split them into control, original version, and the modified versions, almost 1,000 students across all of those. And we're able to look at success, meaning did they pass the course, did they master the key outcomes, and did they come back? Did they come back? Because you're not successful if you're not coming back. And we were able to show large increase in the wild from actually doing this. The students in the redesigned courses were more than 1.5 times likely to actually be successful, which then gave permission to Kaplan to begin doing a whole range of randomized controlled trials and working with some outside cognitive scientists and so forth, but all in a learning engineering environment. Real world consequences, real world measures. Okay, the last piece I'll do, and then I'll open it up for a few minutes of questions. So all of this, in a sense, has been very much in the weeds of individual courses, even down to individual screens. And how do you do that? Individual students and dancers in algebra classes, right? Well, so what do you do with a large system? How do you make this work in the large? And so what we're trying to do within CZI is work across the whole ecosystem. What we were trying to do at Kaplan was to work across 20 different learning organizations in Kaplan, 23,000 employees, 1.5 million learners of very different kinds. And so the way we thought about it there and how we're still thinking about it now is to say, this is change management, really. You start by exposing people to what's possible, right? You show them some of the science. You give them those surprises about it's really inconvenient. And those things about long-term memory that experts don't even know they've got. You expose that to them, and you make some examples. You get some people to buy in and to try some things, like that Kaplan University experiment. Then you've got to actually educate folks. You've got to provide training for the instructional designers, for the faculty, so that they start to have the capability to do something on Monday morning. Because it's not enough to hear about all that. And it's like, well, what am I supposed to do with it? I got to get out of here at 5. So how do you, that's why these slimmed down frameworks are very valuable, because they help me know, well, at least I can decide what kind of learning outcome I've got. And then I see there's a few different types of instruction I should be picking from. And oh yeah, it's primitive, I get it. But it is at least a starting point, which you can then refine over time, right? It's great, refine over time, but start somewhere. And then it becomes real work, right? How do you then get it out to have people do it? Wider use, creating communities. We did that at Kaplan, is made a community out of all the instructional designers, because now they all had the same frameworks, whether they were teaching English, whether they were teaching SAT prep, whether they were teaching nurses, whether it was Australia or the UK or the US. They had the same frameworks. They could now work with each other, even evaluate each other's work, which was actually a really interesting process. And the other thing we did, and I commend it to any of you who are thinking about scale, it was our chief financial officer at Kaplan, Matt Seeley, who said, the only way we're going to make Kaplan into a learning engineering organization is if we can train the general managers in a light version of learning science. And every ecosystem has its own version of general managers, whether they are principals or superintendents or deans of departments or all kinds of folks are general managers who are making trade-offs between real estate costs, IT costs, personnel costs, and learning and training costs, right? And the problem is when the general manager has no understanding whatsoever of how learning works, all they can do is manage the cost. They don't end up understanding what could be done and that it might require more investment, and then you will get a payoff because look at the evidence, right? So we actually did that. We began a process of twice yearly conversations between the global CEO and the local general managers, half an hour each, an entire business week devoted to it, only focused on learning trade-offs, learning questions, learning practices, learning investments. And over several years, that caused the general managers to begin to pick this up. Because, you know, primates, right? Nobody's going to let the big silverback know more about learning than they do, right? So they definitely had to figure out how to pronounce validity and reliability without stumbling because the CEO could do it. And that's a starting point for a lot of great conversations about evidence and assessment, right? So off you go, right? And then finally, the evaluation. You know, you tools, rubrics for looking at what you're doing. You have systematic approaches to looking at the evidence, so you can see, is it actually working? And once you have a community of folks, everybody's engaged and wants to know the answer, and so off you can go. And that includes then, you've got to have these detailed measures. I mean, you need those all the way through, but especially for evaluation, you've got to agree on those multidimensional measures. So putting this all together from kind of that, in a sense, microscopic view of how does learning work and how does motivation work and what happens on screens and individual outcomes, which ones are the ones that are supposed to be in long-term memory versus working memory, all the way up to this kind of work. This really is the learning engineering challenge that I think ultimately we all have to do parts in to bring better results to millions, tens of millions, billions of learners around the planet. So thank you very much for your time, and we have a few minutes for questions. It's one in the back. And if you don't ask me questions, I might ask you questions. I'm just saying.
Thank you for your speech. I have a question regarding the diffusion of innovation. What is the relationship between this and disruptive innovation in memory?
And disruptive innovation in?
In memory, and or motivation.
Well, in a sense, you know, getting all of these ideas diffused, they're all going into minds. And therefore, you have to think about it very similarly, that you have to think about how do you get an initial shock of recognition, an initial motivation, an initial head of steam for folks. And then you've got to figure out how do we get enough practice and feedback for folks to actually get good at the things they need to be good at. This is one of the challenges with things like TED Talks. And even this talk, I mean, I should have said right from the beginning, I'm doing the absolute worst thing to you guys, right? That I just talked to you for an hour, right? That's just the dumbest learning approach ever, right? So I'm aware of that, okay? Sorry about that. I'm fully aware of that. And so, you know, really, none of you can, many of you actually already are learning engineers, but some of you who are not, you're not going to be able to walk out of here, even if I gave you the slide deck, and necessarily be able to do this. So part of the diffusion problem is how do we set up those kinds of performance-enhancing environments for teachers, for instructional designers? And actually, coming back to that long-term memory thing, I think one of the key things we've got to get at in our ecosystem is how do we help schools of education begin to transform what they're turning teachers into so that they all walk out already with mastery of these kinds of frameworks or something like these frameworks, so that when they problem solve with their students or they're looking at a new exciting technology from a sales rep, that the frameworks that pop up automatically in their head are not, I watch, I bet that's going to be great, but rather, wait a minute, what is this doing for writing again? Given that I've, you know, read Steve Graham's work on writing and I know the research on this, does this new thing hit on any of those levers? Otherwise, it's not doing anything new for the mind, so why am I talking to you? Maybe it's lowering cost, or maybe it's saving me time. That's a reason to talk with you. But if it's not doing any of those things, so how do we help teachers as well, and principals, and who are general managers and superintendents, to begin to have those frameworks? So this is not an overnighty thing. This is a thing that is going to take a bunch of time to do. But there are known ways of doing this, and the trick is just to apply those. Another question? Ava, hi.
I had one comment and one question. The comment was that it was really nice to hear someone else talk about that experts don't do what they say. And it turned out to be the basis for the way we score writing. you just brought that up, we had experts write, not tell us what to look for in other people's writing, and we found quite broad disparity. So thank you for that. I wondered if you could elaborate on your sense of accelerated evidence, because that's also an issue for us, and I'd be interested in how you've been thinking about it.
There could be several meanings to what you just said, accelerated evidence. Do you want to be more specific, or just let me riff?
Sure, no. Well, I think what you were, I mean, they're two different, for me, there's probably two big buckets, but let's say trying to find out compelling evidence in a quicker way for the quality of interventions or innovations.
Yep. And one of the key issues that is often, I think, missed, because a lot of people in the ecosystem are all grumpy about things like randomized controlled trials, and are all grumpy about things like testing. It's like, oh, we hate testing. Testing is bad, right? And so somehow we have created a kind of a community mythology of this stuff that is not connected to the real work that we know. So for example, evidence has got to be tied to the decisions you're making and the risks of getting things right or wrong. I mean, in an engineering sense. Now, if you're publishing, p-value 0.05, are there any questions? I'm being silly, but I mean, you know what I mean. But in the real world, if a thing is not expensive to do and the consequences of getting it wrong are an extra 20 minutes on an activity that, oh, oops, it's not so useful for you compared to you, but the promise looks like this could be pretty good, and it's cheap, you might well go ahead with pretty limited evidence, and I've only got an 80% chance of being right about this. And you might say, you know what, I'm just going to do it anyway, and then keep measuring, right? That's the other piece, is you don't go blind, you keep measuring. And oops, maybe I discover after a year of doing this at scale that, ooh, that wasn't as good as I thought it was, but the downside is small. Now, if I'm deciding on a brand new chemistry curriculum, right, okay, now I better think about this and look at my evidence a little more closely, because if I get this really wrong, I might nuke students' entire identity as chemistry using human beings along with their skills at this. So there I may want to have a much higher bar for the evidence that I'm using. And then there are methods for getting different bars of evidence, right? And the different levels of evidence. So we've got to be better about that, because that in part can help us accelerate the evidence gathering. Because if you don't have to do a giant 4,000 student multivariable thing just to find out if this thing is usable, you can get the evidence very quickly just by doing 10 people and see if it's usable for them. That's good enough. But the second part of this, and I alluded to this earlier on, is one of the exciting things now is if we start to modify the instruments we're using to throw off even more evidence about what is the process the user is going through, how are they thinking about things, even their timing, how much time are they taking, there's a lot of research showing all of that information can be used in a valid way to test hypotheses about how learning is going, how motivation is going, as well as identity development and other things. And I think that's a key thing that we all need to be thinking about, is how to do that. The final piece I'll say about that is, and we're doing some work on this within CZI, is setting up more and more environments that can be good at doing the kind of measurable, iterative innovation work that's needed to create better and better products for our ecosystem. I mean, look at how diapers are created, right? Procter & Gamble get some more science on the material stuff, and they make a new prototype, and they have all these little babies and families running around, and they videotape them, they're all cute, they're falling over, it's really funny. But if it doesn't work, it's like, oh God, we gotta go back to the lab. And they don't release it until they've shown through the pilots that they've actually achieved their performance goals with the diaper. I would argue a lot of educational interventions are less well designed than our diapers are, which is unfortunate, right? We should figure out how to do these iterative cycles in the field, in practice with teachers. And a piece of that, a lot of research has started from researchers, and then students and teachers help out, and then an essay is published, an article is published, somebody gets a PhD. So that's a great route. What we also need are starting from deep problems of practice, linking researchers into those, developers to take the research ideas and make them practical, come back through and now iterate, and begin that sort of iterative product development cycle, which will increase the speed at which interventions will begin to improve and become more usable and generate information. So we need to set up more of those. There aren't very many places around in the US where you can find those kinds of things going on. And I think we need those. We need to make those and get those to work. So is there time for one more? Is that all right? One more, last one, yes.
Yeah, it actually leads into what you were just talking about of this iterative process. So I work at a nonprofit, an education nonprofit, and my main job is bridging theory with the actual intervention. And I'm looking at your scaling process because that's where we always end up kind of falling, right? And then you get a lot of human error. So what I'm wondering is how do we scale when we have issues like staff turnover rates, or when we have these very real issues that are affecting the way our kids learn, what they're learning, and then also our overall impact in the community? I'm just wondering, like, how do we bridge that to make it practical and actionable?
Boy, that's a big problem. But I actually think there's kind of multiple pieces to it. I mean, one simple piece is, and by simple I don't mean it's simple to start, it just is a simple idea, is as people come on board, begin by giving them the training that's needed, grounded in the learning science, grounded in good psychometric theory about choices of assessments and all this, grounded in good evidence for their role. And for some of them, that's going to be a little bit of cold water. For some of them, it's going to be, well, thank heavens this is finally here. But just to start from that standpoint, I mean, most complex cognitive work requires an on-ramp. And so that means, yes, we have to prepare for an on-ramp. And so that could be, I didn't show this, but at Kaplan, we ended up building a training program for instructional designers that was 40 hours of online work, followed by 3 months of part-time design work in a group coached by a good evidence-based instructional designer so they could actually apply the principles to a problem that they thought was important and get immediate coaching on it through every step. And then they were ready to keep going in their own work. So like real training, not just here's a lecture, how come you're not doing it yet, right? Because that's not how minds work. So that's a piece. The other piece is what I said before, is trying to figure out how do we get everyone coming into this early on to have these frameworks and ideas. Imagine if, in the face of all the research we've got about immunology, disease, physiology, and all this, if our medical schools were still making sure that everybody mastered the 4 humors. 4 years of focus on the medieval theory of health, the 4 humors, okay? And then they emerge into a world of rich evidence and all this, and 10 years later, they are decision makers and leaders. I bet it would be a pretty strange healthcare system we'd be looking at, because they had not started their careers by mastering something close to what we understood the evidence was telling us to do. So it would be great to figure out how to line up all kinds of early training so that people came out with principles grounded in evidence as well as details grounded in evidence, and then that could carry them through to making decisions as things kept changing and new information came along. Now that's a larger slog. That's not a your organization thing, right? That's like a big thing. But the you thing is, well, why don't we start up with training on this? Why don't we get that going first and then have some experts who then coach and can answer questions in the way that lots of complex cognitive skills are mastered? So I'm between you and lunch, so I think I better stop now. So thank you very much, guys. All the best.